Welcome back to another blog. This is James Kelly. It's May 24th, 2017, and this blog post is called Serverless. It can smarten up your DevOps and infrastructure stack. If you want to check out my blogs, this one happens to be on dzone.com, but they're always on jameskelly.net first, or you can follow me on LinkedIn. Here we go. As IT organizations and cultures reshape themselves for speed, we've seen a trend away from IT as a service provider to IT as a collection of smaller microservice provider teams, each operating and measuring like autonomous micro product teams, and each building and running technology systems as microservices. Now, you've heard me cover the intersection of microservices and containers quite a bit, along with container as a service or Kubernetes or platform as a service or OpenShift and that kind of orchestration. And in this blog, I'm going to change it up a little bit and talk about the other kind of microservices building blocks, code functions. So here I'm talking about microservices run atop of a serverless computing, aka function as a service, or FaaS, you'll hear me say, FaaS stack. Now, serverless is a 2 years new yet already well-covered topic. And if you need a primer, this one, see the link, is the best blog that I've found as a primer. In my last blog, I examined avoiding cloud lock-in by bringing your own DevOps and software-defined infrastructure stack. In other words, bringing your own open source standard tool chain across public and private infrastructure as a service, you maintain portability and harmonized, if not unified, hybrid cloud policy. This software-defined infrastructure stack underpinning the user or business-facing applications is also just a bunch of software applications. FaaS is just one more example of an increasingly popular app developer technology that can be employed by infrastructure developers too, though this one hasn't gotten that much attention yet, not in that regard. So if you read the primer, the link above, you won't have learned about the popularity of FaaS systems like Lambda, but to reduce developer friction, how it's led to a number of open source projects like OpenWhisk and others that sit atop container or platform as a service, such as Fission or Kubernetes. If a FaaS is likely to exist in your application stack, it may as well make sense perhaps to standardize on incorporating one into your DevOps toolchain and infrastructure stack as well. Let's see. I&O events. When it comes to I&O events, does your mind go to a pager waking up somebody in the middle of the night? Ugh. Better to wake up a function and keep sleeping. The main area of natural applicability for FaaS is in event processing. Such code functions, after all, are event handlers. In the DevOps world, for development and application lifecycle events, FaaS presents a simple way to further automate. The scale is probably low for most CI/CD events, so the main benefit here of employing FaaS is the simplicity and the agility in your pipelines as code. It also helps to foster the change and the process innovation to do pipelines as code in the first place. In the DevOps area of continuous response, you'll hear me say CR, that in fact Randy Bias coins here, see the link in the blog, there is almost certainly more scale and importance to respond to events, where the property of FaaS to handle on-demand bursty scale could be a significant benefit. In the software-defined infrastructure world, there are traditional events such as change logs, alarms, security alerts, and modern telemetry and analytics events. Of all of the types, analytics, telemetry, and security events, well, they strike me as the area where FaaS could present the biggest benefit and most interesting examination here. Similar to how for CR, analytics for an application, in other words, processing telemetry, such as API calls, clicks, and other user events, well, they need scale. Software-defined infrastructure is increasingly generating massive amounts of telemetry data, and it needs processing. Systems like Juniper Networks, AppFormix, and Contrail Networking actually already do some telemetry collection and processing. You can see for yourself, see the link in the blog. AppFormix, a platform for smart operations management, in fact, it processes much of the telemetry with light machine learning on the edge node on which it's generated, so that sending that big data for centralized heavy-duty crunching and machine learning in the centralized control plane is more efficient. And we at Juniper Networks have written before about this distributed processing model and its benefits, such as realer real-time visibility monitoring to show you what's happening. Because the DevOps call, you build it, you run it, sounds great until you're running in a multi-tenant, multi-team, multi-app, etc. environment, and chaos ensues. AppFormix also has a smart policy engine that's using static thresholds as well as anomaly detection to generate, you guessed it, events. Just like DevOps event hooks can trigger a FaaS function, so can these software-defined infrastructure events. So obviously a system like AppFormix implements much of the CR machine learning smart glue for the analytics of your stack and its workloads. Smart driving ops, as I call it. Other systems like Contrail Networking with its analytics Kafka or API interface are rawer. The same is true of other software-defined infrastructure components like raw Kubernetes watcher events, with which actually some FaaS systems like Fission already integrate. The more raw the events, I bet, the more frequent they are too. So you have to decide at which point the frequency becomes so high that it's more efficient to run a full-time process instead of functions on demand with a FaaS. Now that depends on the scale with which you want to run your own FaaS tool, or use a public cloud FaaS service. And of course, that probably only makes sense if you're running the stack on that public cloud and want to trade off some lock-in until they're mature as usable in a standard way. It's worth seeing this link to the serverless framework here. To what end? One of the ends that you could have in mind to run operational based functions is greater operational intelligence. As we've discussed, AppFormix does this to a good extent, but it does it within a cluster. We can consider further smart automation use cases in cluster, but using a FaaS external to your clusters, your infrastructure developers could scope your intelligence deeper or broader too. For example, you could go deeper, processing telemetry in customized ways that AppFormix does not today. Imagine you're running on GCP, the Google Cloud Platform. Well, you could do deep learning on telemetry data, even with TPUs, I might add. To borrow a metaphor from a common ML example of image recognition, where AppFormix, for example, might be able to tell you, I see a bird. Well, a powerful deep learning engine with TPU speedup, for example, may, in real enough time, be able to tell you, I see a peregrine falcon. It's a little bit more specific than I see a bird. It's better. In more practical terms, you may be able to go from detecting anomalies or security alerts to operations and security situational awareness, where your systems can run themselves better than humans. And after all, they already can at lower levels, thanks to systems like Kubernetes, Marathon, and AppFormix. Rather than deeper, broader examples could be use cases that extend beyond your cluster. For example, auto-scaling or auto-healing of the cluster by integrating with physical DCIM systems or underlying infrastructure as a service. Yes, it's serverless, managing your servers, folks. Okay, in closing, there's plenty more to be written in the future of serverless. I expect we'll see something soon in the CNCF, and then we'll definitely start hearing of more application use cases. But hopefully, this blog sparked an idea or two about its usefulness beyond the frequent HTTP request and API callback use cases for high-level apps. Share your ideas if you're reading the blog. Otherwise, go and throw in a comment. For intent-driven, self-driving, smart driving infrastructure, I think a FaaS track is emerging. Thanks for tuning in.